when you have questions. All right, so we're fixing to start on 4.1. So, here we go. 4.1. It is going to be graph, quadratic, functions in standard form. All right, graph quadratic functions in standard form. Okay, I'm just trying to get my stuff together. All right, so let's see what this means and what this says. When I say the word quadratic, what comes to mind?
That weird equation math.
You what? All right, so think about the memory test, because I'm pretty sure you all had a memory test. And it had the functions for them, and one of them was quadratic. What is it? Yes, exactly. It is an x squared. Whenever I say quadratic, you need to go, oh, that's an x squared. Okay? Don't let your brain go quadrilateral 4 and think 4. Okay? A quadratic is an x squared. What's it going to look like when you graph it?
A parabola.
A parabola. Very good.
Or a parabola, you know that.
Okay? So a v is an absolute value. Remember that. A v is an absolute value. So this is a quadratic, an x squared, and it is to look like a v. So graph quadratic functions in standard form. So this is what standard form looks like. Ax squared plus bx plus c equals 0. That's standard form. Whoa, wait a minute. We got a problem. Like, how am I going to graph this when all I, now y'all a, b, and c are numbers, okay? All I have are x's. There is no y.
X equals negative b over 2a.
No. Do what? Oh, look at there. Alexi says you just replace 0 with y. 0 and y are interchangeable. Okay? Y'all, listen to me. You probably didn't even know this, but did you know that if you wanted to solve all those equations you had to solve, if you set them equal to 0 and then replace that 0 with a y and graphed it, wherever it crosses the x-axis, that's your answer. Okay? All right? We'll get to that later. But, yes, that's how we're going to graph it. All right, so when I say quadratic, what do you think?
X squared.
X squared. That means it has an x squared. Okay, what if I say linear? What does that mean? No?
It's a line.
So, what is that going to be? Just a what? Somebody said it. X. Like said, just an x. So, if I'm talking about the linear term, that's the x term. Look there. There's my linear term right there. X to the first. You know why that's the linear term? Because an x to the first, when you graph it, is a line. Okay? This is my quadratic term. X to the second.
Oh, that reflects on itself.
Okay? Yes, it will. Sure will. All right, so let's talk about the parent function. F of x is equal to, what's the parent function of a quadratic?
F of x equals x squared.
That's it. F of x is equal to x squared. If you graphed it, all right, if you graphed it, it's just a parabola. It looks just like this. Are you with me?
Yeah.
Okay, so this right here, this point that's right here at the origin in the parent function, what's that point called on my parabola? Is what?
Vertex.
Is vertex. Very good.
Let me show that one.
Yeah, it's his vertex. Now, I'm just gonna tell you this, okay? And look, after a while you'll get used to it, but right now when I first say it, it throws a lot of kids off. But this vertex is just a point. Do you agree? Okay. Because of what this is, I'll explain in a second. The vertex is called HK. HK. The H is the X value and the K is the Y value. The reason that it's called that is because a parabola is a conic section. A conic sections. There's 4 conic sections that we study, all right? They're parabolas. This is what a parabola looks like, okay? There's a circle. You know what a circle looks like, right?
Is that a K or
K. H and K. On a circle, it's the center of the circle. We call it HK. There's an ellipse. What is an ellipse?
Isn't it like that bicycle thing?
Yeah, an elliptical orbit. Yeah, it's like an oval. That's an ellipse, okay? And his center is called HK also because he's a conic section. And the last one is a hyperbola. At the end of the year, we will study these conic sections just a little bit, and then next year in pre-cal we study them a lot more. All right, so everybody okay so far?
What does that say before section?
Conic.
Conic, C-O-N-I-C. It's called a conic section. I'll try. I don't know that I can do it right here on this little machine. Or where the people that are, if they're listening, will know what we're doing. But anyway, I'll show you. Okay, so do you agree? I don't have time much to do this either. So, do you agree that this is a cone?
Yes.
Are you with me?
Yeah.
Okay, so every conic section is, you get from taking a cone and cutting it with a plane. Not like an airplane, but like a plane from geometry, which would just be a flat sheet of paper. So if I took a flat sheet of paper and I cut this cone straight across here, just like this. You see? And it goes right through it. Then when I pick the cone up and showed you the front that I just cut off, that would be a circle. Do you agree? Okay? If I slanted it like this and I cut it, then when I showed it to you, that would be an ellipse or an oval. You see what I'm saying? So a parabola's they're all gotten from it. So we'll study that later. We're not going to do it right now. Okay, so everybody okay. One more thing we got to talk about, this right here. This line right here is called your axis of symmetry. Axis of symmetry. Notice that it goes through the vertex. Notice that if you folded it on the axis of symmetry, that one side of your parabola would fall directly onto the other side of the parabola. Is everybody with me? Okay, it is symmetrical about this axis. That's the way we say it. What kind of line is this right here? It's a vertical line. All lines are straight. Do you agree with that? Okay, so it's a vertical line. How do you write the equation of a vertical line? X equals. X looks like 4 V's all stuck together. He is screaming at you. He's a vertical line. X equals. Now y'all listen to me. This is called a thinking skill right here. All right? It's a transfer of knowledge. What does X have to be equal to if this thing goes through the vertex?
It equals Y.
Oh, who said that? Oh, and you're so good today. Very good. X is equal to H. Why? Because H is the X coordinate, the X value on the coordinate. Okay, do you see what I'm saying? In order for it to go through this point on the vertex, what is the X value? H. So X equals H. Now, let me explain to you, because this is where the problem's going to come in. When I ask for the axis of symmetry, some of you are going to shout out a number. Is the axis of symmetry a number? No, it is not. So you have to say X is equal to that number. You can't just say the number. If you do not write it as a line, you will not get any credit for it. Does anybody have a question? Everybody okay so far? All right, so here we go. Now what we're going to do is we're going to look at this equation right here, but I'm just going to look at a really easy part of it. I'm going to take the linear term out. I'm going to take the linear term out. Which one's the linear term? Bx. So I'm only going to look at it like this first. We'll start off easy. Y is equal to ax squared plus c. Okay, so let's talk about what effect this A has on this graph. Okay, what effect does A have on this graph? What does A do to my graph? Well, first of all, if A is positive, what happens to my parabola? He opens up. See, you already knew that. Okay, if A is positive, he opens up. What if A is negative?
No.
Yeah. Then he's going to open down. Okay? Now, since I've already talked about the sign of this number, this coefficient of the quadratic term, you hear all that vocabulary in there? Okay? If I'm already talked about the sign of the coefficient of the quadratic term, let's just talk about the number. Okay? So do you agree that I could take the absolute value of that number and that would pull that sign off? Okay? And then I would just be talking about that number. Okay? So that number, what if he's greater than 1? What if he's greater than 1? Now, first of all, let me make you understand. Do you remember when we did absolute value functions? Those were the V's. Remember that? Okay, if there were a number out front of your absolute value, did that affect your Y or your X?
Y.
That's your Y, right? And if that number were bigger than 1, that stretched that V, right? And what happened to him? He was like this. And what happened to him when you stretched him?
You got skinnier.
He got skinnier, like this, because you stretched him up and he got really skinny. Okay? Well, what if that number right here was smaller than 1? What happened to him? That was a vertical compression, and when you compress something, it spreads out like that and gets fatter. Okay? Y'all, this is the same exact skill. Okay? So if the absolute value of this number right here is greater than 1, is my parabola going to be wider, narrower, or the same as the parent function? Narrower. Very good. Okay, now let me tell you what I just did. I tried to explain to you why this happened so that you don't have to memorize this mess right here. You understand it. Everybody got it? Okay, so what if the absolute value of A is less than 1? But he has another restriction. Because he's an absolute value, what is he always going to be greater than?
0.
0. Okay, so he might be less than 1, but he is going to be greater than 0. Okay, so if he's between 0, now y'all, he can't be 0 because then you wouldn't have an x squared, okay? So that's why I didn't put the equal sign there. So he's between 0 and 1. Some kids like to think about it as a fraction or something, all right? We don't use that word fraction because I could put 3 halves, and that's a fraction, but that is not this guy right here. That's this guy, okay?
So you said it was greater than 0?
And less than 1.
You put the sign wrong. Or is that how
No,
you put it?
look, if you read it, the absolute value of A is greater than 0, and he's less than 1. Remember how we, okay? And remember how we talked about these signs? What did I tell you about these signs? What do they always have to be? The same way. You never have them facing to each other or away from each other.
Okay,
Okay? That would not be proper. Okay? All right, so y'all quit cutting and whatever you're doing. All right, so here we go. He's between 0 and 1. Would my graph be wider, narrower, or the same?
Wider.
Okay? What if the absolute value of A is equal to 1? Yeah, then he doesn't change, so he would be the same. I'm going to show you a picture of that. Okay? I'm going to show you a picture of that. So I'm going to get my calculator out. I'm going to delete some stuff on there. All right. So everybody agree? Everybody agree that this is my parent function. Are you with me? Okay. So let's say that we make the absolute value of A greater than 1. Greater than 1. He should be narrower. All right. So I'll go down here. Let's make it a 4. 4x squared. Now we just got finished saying that this 4 is he's on the y. Okay. He's outside of the x, because what would you have to do first? Square that x. That's your PIMDALs. Okay? So he's affecting the y. That's a vertical stretch. That's going to make that thing skinnier. Here's what it looks like. Is he skinnier?
Yes.
Narrower? Yes. Okay? So let's go in here. And this time let's make it between 0 and 1. So I'm going to go second and insert a 1 divided by. So now I made it 1/4. Are you with me? Okay, so I'm going to graph it. This should be wider. There's your parent function. And there's the original function. Okay? Of course, 1 would be the same because that is the coefficient of my parent function. Anybody got a question? Okay, so let's talk about what C does. All right? Now listen to me. C, is he with an X?
No.
No. Y'all, if he were with an X, he would have to be in parentheses with the X. So if he's not with an X, he's a Y. Do you agree with that?
Yeah.
And Y's move where? Up and down. How?
Because they're
How?
just like you.
Just like you think. That means a positive moves where? Up, and a negative moves down. Okay? So if C is positive, he moves up C units. Okay? If C is negative, what does he do?
Goes down.
Yeah, he moves down C units. Okay? So let's graph some. These are really easy, guys. Okay? These are really easy. I think you'll get these. We're going to work 2 of them. So here we go. Y is equal to 1/2 x squared plus 2. Okay, so I'm going to ask you some questions. We are going to graph this, so I'll go ahead and just draw me a little graph over here. Okay, so I'm going to ask you some questions, and before you shout the answer out, I want you to give it about 5 seconds so everybody has time to think about what the answer is before you shout it out. Okay? If you want to be first, then write it on your paper first. Okay? So here we go. My first question is, give me 5 seconds. Does this parabola open up or down? Does this parabola open up or down? What do you say? Reason? No. What's positive? Your attitude? What's positive? Now,
X squared is positive. Right?
Your A?
the coefficient of the
X squared.
quadratic term is positive. You see, I'm trying to make you use some vocabulary. Does everybody understand that?
Yeah.
The coefficient of the quadratic term is positive, so that makes my parabola open up. Okay, my next question, give me 5 seconds. Is this parabola wider, narrower, or the same as your parent function? Wider, narrower, or the same as the parent function? What do you say? Why?
Because it's in between 0 and
Why? What is?
Because your
The coefficient of the quadratic is
greater than 1.
less than 1. 1/2.
Oh crap.
Okay? Less than 1. Y'all, this is the coefficient of the quadratic. This is the quadratic term. Remember when I say quadratic, what are you supposed to think? X squares. If I say linear, what do you think?
dx.
Just an X.
Oh, just
Okay? So the coefficient of the quadratic term is between 0 and 1, so that makes him wider. That's a vertical compression. Are you with me? Okay? So let's graph him now. All right? Let's graph him. So, does he go left or right any? What does that plus 2 do to him? Up 2. So his vertex is right here. Do you agree?
Yes.
So what is his vertex?
0.
Very good. 0, 2. Hey, what's his axis of symmetry? Oh, very good. X equals 0. It goes right here, right through that vertex, okay? Now watch, I'm going to tell you a secret. Y'all, you can only do this 1 time. How many times can you do it?
1.
If you do it more than once, you'll be wrong. Does everybody understand that? How many times can you do it? Once. Do you remember on the V how this was my slope? And we could go up 1 and to the right 2 and to the left 2? And you could do it as many times as you wanted to? Because a V made a straight line. Do you understand that? It was a constant. That's a constant slope. This is not a slope, but I can kind of cheat and use it for a slope. How many times? 1 time. Because it's a curve, you can only do it 1 time. If you do it more than once, you make straight lines, people, and that's not what a parabola is. So I can go up 1 and over 2. Up 1 and to the left 2. Can I do it again?
No.
People, you can only do it 1 time. Okay? I said that like 6 times. There will be 3 people in here that have no earthly idea what I'm talking about. All right? So whatever you're daydreaming about, knock it off. Pay attention. So there it is right there. That's what your curve looks like. Anybody got a question?
What about the x squared? Like,
The x squared is what makes it a parabola. Okay? If you didn't have an x squared, it'd be a line. All right, so here we go. Your next one, y is equal to negative 2x squared minus 4. Let's draw us a little graph, because that's what we're going to do.
You're not gonna check to make sure it goes through any other points?
No, but we will later on. Right now, we're just kind of being, we're just kind of sketching it. Really, all I'm trying to get you to see is that this number in front, the coefficient of that x squared, he's going to tell you if he opens up or down. He's going to tell you if he's wider or narrower. This number out here, this constant, he's moving it up or down. Obviously, we're fixing to pull in this linear term, this bx. What's that b going to do to it?
And
Move
it's
it
gonna
where?
change the,
left or right?
Yeah, he's going to move it left and right, but he's not pretty, people. He doesn't just like, if it's 5x, he doesn't go right or left 5. It's not pretty, so it takes a little more finesse to do it. Okay, so here's my questions. Give me 3 seconds. So, does this parabola open up or down?
Wait,
Sorry.
That's okay. So, does everybody agree?
Yeah.
This parabola opens down. The coefficient of the quadratic is negative, so that makes him open down. All right, 3 seconds. Does this parabola wider, narrower, or the same as the parent function? What do you say? Narrower. The coefficient of the quadratic is greater than 1. Okay, the absolute value of him is greater than 1. You can't really say he's greater than 1, but the absolute value of the negative 2 is 2, and 2 is greater than 1. All right, so some people like to graph first because they're very visual learners. So let's see, this parabola, he's starting here like the parent function. I know he's going down. What does this minus 4 do to him?
Bring him down.
He makes him go down 4. 1, 2, 3, 4. Okay, can I draw him right now?
No.
why not?
Yeah, I can I?
Yeah,
Can I draw him right now? What am I going to use to draw him?
slope.
the slope.
It's not really a slope. You can't call it a slope. That's why I haven't called it a slope. Okay? But I'm going to use this negative 2. Do you understand? Why can I not call it a slope? Because a slope is something that's constant. Is this negative 2 constant? How many times can you use it? Once. You use it more than once and you're wrong, people. Okay? So I can go down 2, and to the right 1, and to the left 1. And there's my parabola. Okay? What is his vertex?
0, negative 4.
0, negative 4. Are you with me?
Yeah.
Okay. What's his axis of symmetry?
X equals 0.
Very good. What's going to be the careless mistake that someone does on their paper? 0. They're going to write 0 down. Okay? So if you write 0 down, I will mark it wrong. And y'all, it's on every stinking problem. So you're missing that point on every problem on that test or that worksheet. So it has to be x is equal to 0. So here it is right here. We are going to draw it because in this next problem that we're fixing to do, which is the last problem, we are going to use it to find everything that we need. Anybody got a question about these?
No.
Those are pretty easy. Is everybody okay?
Yeah.
Is this really difficult?
No.
Didn't you know most of this stuff?
I was
Okay. All right. So let's do this. We're going to try one. Now we're going to throw that linear term back in there. Y is equal to ax squared plus bx plus c. Okay, so obviously this c is moving this guy up and down. This b is what is going to move him right or left, but he's not pretty. Okay, so, and here's why it gets confusing, because right now we're graphing them in standard form. Next, we're going to graph them in vertex form. And then we're going to graph them in intercept form. Do you understand why kids get mixed up? We're doing the same thing, but we're doing it 3 different ways. Okay? So, so let's do it this way first. My vertex. What did I tell you your vertex always was?
0.
What?
HK.
HK. Okay? HK is my vertex. Alright? So, y'all, you can't look at it and tell what it is, so there's a formula to find H. You have to know it. Does that mean you have to memorize it? Yes. So every time you use it, you write it down until it's stuck in your head. Alright? H is equal to negative B over 2A. The opposite of B over 2 times A. Okay? Now, once you find H, you're going to plug it in this equation, and it's going to tell you K, which H is just the X value of the vertex. K is simply the Y value of the vertex. Okay? So how do I find K? Yep. Plug H in. Plug it in, plug it in. That's all you have to do. All right, is everybody okay? It's the last problem. Example 3. He's going to look like this. So y is equal to 2x squared minus 8x plus 6. We are going to talk about all those things, and we are going to graph him. This is what most of the ones on your worksheet will look like, and your test. All right, here we go. Are you ready?
No,
No?
I'm drawing a graph.
What time's the bell ring? 45? Oh, we're good, we're good.
Okay, that means.
Okay, I got time to give you. Okay, so here we go. The first thing I want to know, I'm just asking you questions about your graph. Can I look at this graph and tell a lot of things about my parabola? Yes, I can. So my first question is, 3 seconds. Does this parabola, write the answer down, does this parabola open up or down?
Up.
Yes,
Oh,
he opens up. Okay? My x squared is positive. The coefficient of that quadratic term is positive. Okay? Give me 3 seconds, write the answer down. Is this graph wider, narrower, or the same as the parent function? What did you say? Narrower. Who's telling me that? What number up there? Yeah, that 2 right there, the coefficient of that quadratic term. If the absolute value, take that sign off that number when we talk about if it's wider or narrower, okay? If the absolute value of that number is greater than 1, he's narrower. If it's between 0 and 1, he's wider. If it is a 1, he's the same. He's the same. Okay, so now we're going to find the vertex. Can I look at it and shout out the vertex?
No.
Then that means that you need to show me some work. Do you understand that? Okay, so what's the formula for H? Negative B over 2A. So H is equal to, that's the same thing as the opposite of B. What's the opposite of a negative 8?
8.
Over 2 times what's A?
4. Or 2.
2. Okay? Does everybody know where we're getting these numbers? Here's where they come from. Just like when you did the quadratic formula in the 8th grade. AX squared plus BX plus C. So there's my A, there's my B, and there's my C. Make sure you pull signs with those numbers because they do go with them. Okay? So what is 2 times 2?
4.
And 8 over 4 is?
2.
So my vertex, H is 2. The X coordinate is 2. Okay? How am I going to find K?
Plug it in.
Plug it in, people. Okay? So K is equal to, plug this X in that equation right there, and he will tell you what the Y value is, which is my K on my vertex. So 2 times 2 squared minus 8 times 2 plus 6. What do you have to do first? What does PreAPAlg say? Exponents. What's 2 squared?
4.
What's 4 times 2?
8.
So 8 minus, what's 8 times 2?
16.
Okay? I'm not a good subtractor, so I only want to subtract 1 time. So I'm going to add on my positive. So it's 8 and 6.
8.
What's 14 minus 16? So my vertex is 2, negative 2. Do I have any questions?
No.
So to the right 2 and down 2. That's my vertex. What's my axis of symmetry?
X equals
X equals 2.
Oh, I did that
Yeah.
wrong.
X equals positive 2. Okay, what's the X value, guys, of your vertex? 2. So X equals 2. So we're going to do it. Draw a little axis of symmetry. Okay, now here's the big deal. You must graph 5 points. How many points do I have right now?
1, 2.
1.
Oh.
I just got this one right here, right? So I'm missing 4 points. Now watch what I'm going to do. I'm going to do a T-chart. Y'all listen to me. On my T-chart, I'm going to do 2 points. I'm going to reflect those 2 points through my axis of symmetry and create 2 other points. So then I'll have 4 points, and all I had to put in my T-chart, all I had to find were 2 of them. Okay? So could I pick any X that I wanted to put in my T-chart?
Yeah.
Yes. Could I pick 72? You could, but y'all, the bell would ring and you would be on problem number 1 and still drawing tick marks on your graph. Okay? So 72 is not a good choice. You can pick anything that you want to pick. Alright? I'm going to tell you what I pick. I start from the vertex and I pick 2 points on one side. I always go back to the origin. Eric? Happy. I always go back to the origin. Why? Because I'm trying to keep my numbers small. Are you with me? Okay? Now let me ask you a question. I'm obviously going to pick 1 for my x's. Do you understand? Would it be wise to pick 1 and 3?
No.
Yeah, y'all, look, once we find this 1, I'm going to reflect it through the axis of symmetry, and that'll give me this 1. Then you just wasted it. Okay? You're going to have to go find some more over there. All right? So I'm going to pick 1 and 0. I'm going to say it one more time. I start where the vertex is, and I pick 2 points on one side. 2 points on one side. I always go back to the origin because that tries to keep my numbers pretty small. So I'm going to pick 1 and 0. Do you have to pick the same points I do? No, you don't. I usually have different points on my graph from kids that have done different things. But do I want to hang around this vertex? Y'all, if this number right here is really big, you better stick close to that vertex because the farther away, the higher they're going to be and they're going to go off your graph really fast. Okay? So I'm going to pick 1 and 0. So let's plug them in. Here we go. This is my x. Plug it in up here and it'll tell you what y is. So 2 times 1 squared minus 8 times 1 plus 6. What's 1 squared? What's 1 times 2?
2,
What's 8 times 1?
8,
What's 2 and 6?
8,
What's 8 minus 8?
0.
Boom. 1 is 0. Okay, now watch this. Remember how many times can we do this number right here? One time. Up to and over. He's right on target. Okay, now let's plug 0 in. Oh my word, I love 0. Watch what this stinking 0 does. When you plug 0 in this term right here, what happens to this term? He goes away, people. 0 squared is 0. 0 times 2, 0. Boom. What happens when you plug 0 in right here? He goes away. What's my answer? 6. So at 0, he's 1, 2, 3, 4, 5, 6. Now, do you understand why I'm hanging close to this vertex? All right? If you picked -1, is it going to be on my graph?
No.
People, he's not going to be on my graph. Do you understand why you can't go up 2 and to the left 1 again? You'd be wrong. Okay? Now watch what I'm going to do. I'm going to reflect these points through this axis of symmetry and get me 2 points over here. That will give me my 5 points. So here's the way I do it. 1 to get to the axis of symmetry, and 1 to get away. Are you with me? What am I going to say up here?
2 to get away.
2 to get to the axis of symmetry, and 2 to get away. and here is my curve. And it is a curve. Please don't make it with pointed, sharp, straight sides. It doesn't. It's a curve. Does it have 5 points on it? Yes. Montana.
Can you also start with the vertex and go over and square it to find them? Like,
Now, okay, so listen to me. When I use this little 2 up here, that's not what I'm looking for. Can I use it as a check? Yes, I can, to get these first 2 points. I want to see your work right here. Okay, obviously with the 0, I didn't show a lot of work because I didn't need a lot of work. Okay, he made everything disappear except the constant. But this guy, I showed my work. I showed my work how I found H. I showed my work how I found K. You understand? All right, I must be boring today. All right, so 2 things to talk about and then I'm finished. Maximum and minimum. Maximum and minimum. Now, when I talk about maximums and minimums with a quadratic, what point on that parabola am I talking about? The vertex. I am referring to the vertex. Okay? Now, here's my question. Does this graph right here have a maximum value? No. These arrows say this graph keeps going up and up and up and up and up. He does not have a maximum value. What would this value be called?
minimum.
His minimum. So in order to have a maximum value, how does my parabola have to open?
For a minimum?
A maximum value, how does my parabola have to open? Down.
Oh.
Do you see what I'm saying? See, if he goes like that, that's my maximum value. Okay? And in order for him to open down, what does this quadratic term have to be? Negative. Could I say it like this too? That A must be less than 0. Does that all say the same thing?
No.
Yes?
Yes.
Yes?
What?
The quadratic term has to be negative. A must be less than 0.
Yeah, that's right.
That's all the same thing, people. Okay? In order to have a minimum, this guy has a minimum, right? It's right here. Okay? It's right here. Later on, we'll talk about what the x value says and the y value. Specifically, which one is your minimum value and which one gives you the minimum value. We'll talk about it later. Okay? So, but to have a minimum, how does my parabola have to open? And if it opens up, what does my quadratic term have to be?
A is greater.
And A would be what? Greater than 0. If you're going to make it positive, people, it's got to be greater than 0. All right, anybody got a question? Was that bad? That was all in section 1. Should you know how to graph a standard form quadratic? Yes. Okay? Yes.